Thanks. Yeah, that works. Good morning. I took the liberty to change the title a bit. I think I got the title TraIT, Translational Research IT, but I added the bridge over the Valley of Death, and I will show you in a minute why I did so. This is what I'm going to talk about you today. First of all, why am I here? So a bit of context from my personal situation. What is the problem? How are we going to solve it in the Netherlands? And then the core of the presentation, practical solutions from the TraIT and the BBMRI in Netherlands network. So one slide on my own background. So my employer, a ligature, is a small foundation in the Netherlands that I quickly want to introduce in this single slide. We are basically operating on the boundary between diagnostics research and drug research, area of precision medicine, and we are a program management organization. So we are running large projects in the Netherlands, and that's how I get here. So that's why I'm here. So I'm running a few projects in the research infrastructure arena in this field. So that's the commercial for my employer, and now I will focus on to the projects that I'm involved in. So why do we need research infrastructure? So let's go into a use case. So the role of the HPV virus in cervical cancer screening. This virus was detected in the 1980s, early 1990s, so a few years later, it was clear that it played a very important role in this type of cancer. Nearly 100% of the cancers have this virus. And then only in the Netherlands, so a small country, we run studies around this virus as a biomarker involving 100,000 patients, only in this small country. And it took us 20 years. Then finally, the authorities decided to use it in screening. Took also 5 years. And then last year, finally, we started with the implementation, and we are still having some discussions around it, and basically the clinical trials start all over again. So this takes us, what is it, 1983 till 2016, 33 years. And and that's the time it takes till a result gets to the patient. And when you look at it, so there are it's a multifactorial problem, but lack of infrastructure is one of the reasons, and lack of data quality is another reason. So there's a lot of work to do for us to avoid these very lengthy processes. And that's basically what we call the Valley of Death, or the innovation gap. So it's very hard to get innovation from primary research, basic research, to clinical care. And when you look at when you take it very simple, so what is needed? So back to the basics. So we are in this field because we want to improve health. But when you want to improve health, you need to change current practice. And when you want to change current practice, you want to change guidelines, and guidelines can only be changed based on evidence. And evidence can only be changed when you do the research to do so. And in order to create evidence that is reliable, you need to have excellent infrastructure underpinning this. Only then you can ultimately change clinical practice and improve health. So why is that so difficult? That's because of fragmentation. So we do have all the bits and pieces in place. So there is a lot of efforts in this field, not only in the Netherlands but also in Europe. But it's really fragmented. So it's not a complete solution that can be used by the scientists. So sample collection, software tools, data collections, it's all spread out over the country. And to illustrate that, this is an analysis made in the Netherlands. And don't worry, I'm not going to explain this slide to you, but these are all initiatives involved in research infrastructure in the Netherlands, in the biomedical field. And this is not an inflated slide with all little initiatives mentioned. These are big initiatives. So that's, even in a small country like the Netherlands, we have so many initiatives. And when you draw the same slide in the UK or Germany, it will be even worse. I'm sure about that. So what you need is basically an integrated infrastructure providing the complete solution for personalized medicine and health research. And only then these infrastructures are really used, and only then we can bridge the innovation gap. So a bit of history and where we are heading in the Netherlands. So in 2009, you saw the first big infrastructures coming up. We had lots of biobanks, the CTMM initiative, where TraIT was coming from, the National Genome Initiative. And then in 2012, we had BBMRI-NL, TraIT. 2013, BBMRI and TraIT kind of merged into the new generation BBMRI-NL in the Netherlands. And now we try to basically merge also with ElectioNL, IATRIS, the Dutch University Medical Centers joined, and we basically created an overarching infrastructure called HealthRI. And we believe that with this infrastructure, we do have the critical mass to get all these initiatives sustainable and basically make an integrated solution for them. So, for the rest of the presentation, I will mostly focus on TraIT and BBMRI, and for a good reason they are central in this graph because I created it. But I also believe they are cornerstones of HealthRI. And but please keep in mind when we look talking about sustainability, there is an overarching initiative in the Netherlands called HealthRI, and I believe we should do the same thing on a European scale actually. So that's will take a bit more time. So back to TraIT. So it was founded in 2011. It was a public-private partnership. We started with only a few partners, a few medical centers, a few companies, the Cancer Foundation, Heart Foundation. Quickly, we got a lot more companies, including the Hive, which is also present here. And basically all the rest of the UMCs joined and many more companies. And basically this group of partners created TraIT. So it was really a joint effort. And the basics of TraIT is this very simple scheme. So when you look into translational research, biomarker research, basically what you want to do is correlate a clinical phenotype to to the disease outcome. And in order to understand that, so you have a group of patients with a difference in outcome, but they look very similar. I learned endotypes, that is called. And then you want to understand that from the underlying disease biology and basically stratify those patients. This is the simple scheme in biomarker research. So when you basically wrap out this scheme and look at the underlying workflow, then this is the basic workflow that you see in most of these projects. So a patient gets into the hospital or in a study, a biobank study, for example. You take the clinical data, the imaging data, you take samples, and with these samples you start all kinds of experiments. This scheme you see across disease areas, and that's the basis of TraIT. So this data ends up in databases, and then to address the research question on the previous slide, you need to integrate. And that's where in TraIT, where Transmart kicks in. So it's really the centerpiece of TraIT, where we bring together all the data from these different workflows. But maybe slightly different compared to eTrix. TraIT really tries to support this complete workflow from data acquisition till data integration. And when you look at the way the TraIT website is represented, you see the same thing. We like to see ourselves as a kind of Office 365 for translational research. Like in your Office suite, you have Word, Excel, PowerPoint working together. So we do have a set of open source tools working together, providing the complete workflow you saw on the previous slide. And also here you see then in the data integration, you see Transmart and see Bioportal as the central tools. The website is also organized in this way, basically a do-it-yourself portal. So you can click on it and you get kind of instructions how to proceed with these tools. So to give an example for Open Clinica, which is our case record form that we use, so a well-known open source tool that we have implemented. You click on it and you get instructions what to do, how to get started with Open Clinica. So first page is very simple, so preparation, execution, and close off of the study. You could, that's pretty trivial. But then when you click on preparation, you get a stepwise protocol how to start a study. So if you're not used to the tool, you need training. You need to ask for an ID. You need to build your CRF form in a sandbox environment. You need to test it iteratively till it works, and then you can go to production. Same thing for execution. Also, there are a number of steps that you have to proceed. So this way, we try to provide a self-service portal That's basically scalable, and where we can serve a lot of projects in the same environment with minimal effort. Stepping to the imaging environment, we do have quite a few projects there, open source tools there. One example, NBIA, which is basically the Amazon for imaging data. So it's an research image archive. Images are stored anonymously there, or pseudonymously. And you do have a shopping cart like you have in Amazon, and you can basically order images for download, and you get them back to your PC. So scientists like this very much, very user-friendly. There is a problem, though, to get the images in, because traditionally all kinds of transport mechanisms are used for image transfer from clinical care to research, which are not, it's not the way we would like to do proper research right now. So you need to have a way to transfer these images securely and basically de-identify them. Because in the image format, the DICOM, everywhere you see identifying fields, and you need to strip those fields. So we have a tool, CTP. It's also open source, taken from the American radiology organization, RSNA. It's installed locally in all Dutch medical centers. And you can program this tool basically to determine which fields to remove from your DICOM. And you can program that per instrument and per study, which is very often needed, because in some studies you want to transfer the date of birth. Most other studies you don't want to do that. So you need that kind of flexibility. And then on the TraIT side, there's another CTP which basically listens to the other CTP sites, and they and the images are entered in the study in the TraIT image archives. And not only in NBIA, but also for, interesting. Okay. Yeah. Okay. Let's continue. Not only in NBIA, but also in XNet, which is the other image archive we support in TraIT. Moving on to the next domain in TraIT is digital pathology. So in pathology, pathologists in the Netherlands, they share images for a long time already, and this is the classical way to do that. So they have these slides, they put it in the back of their trunk, or they send it around with FedEx, and they ask each other to look at it under the microscope. But you can imagine that this is a laborious process with lots of risk of lost and broken slides, so it's very suboptimal. So recently the high density scanners came in, where you can basically scan on a 40 times resolution, like you do on a microscope. And we implemented a platform basically to share those slides independent of the scanner vendor. And this system is called TAPIS. So it's shared between the Dutch UMCs. They can look at the slides. And the nice thing is that it doesn't require much bandwidth. So these images are huge, but usually, just like under a microscope, you're zooming in a certain area of the slide where you see tumor cells and things like that. And you do the same thing on the web. So it's like you use Google Maps. So you zoom in a certain area of the map that you find interesting. Same you do in TAPIS. One use case, how this system is used and how you can do things you cannot do without a system like this. So this is a study, the Netherlands Breast Cancer Project, and basically it's looking back at patients from the 1990s. Because in 2000 there was a change in treatment for young women in the Netherlands, and they were treated more aggressively than they were treated before. And now there is the hypothesis that for a certain class of these, a certain subgroup of these patients, that's actually not needed. So what they're now doing is going back to before this protocol change, go to the National Cancer Registry, IKNL, select those patients, young breast cancer patients, go to the National Pathology Archive, where we still have the tissue samples from the 1990s, which is pretty unique for the Netherlands. These are selected, then we scan the slides, put the slides in TAPIS, and then the problem arises, because now we need lots of pathologists to get the numbers and look at those slides and basically classify those slides into patients that would need aggressive treatment and patients that wouldn't. And we found volunteers across the Netherlands, and across Europe. So pathologists that want to participate in this study, but then how to get the slides there. Now, so that's the only way you can do that, get the logistics right for a study like this, is with a system like TAPIS. So basically we send the slides electronically to those pathologists. They look at the slides in TAPIS and qualify the patients, and they enter their findings in Open Clinica to record the results. So this is really a study you cannot do with the classical means. You cannot send around the slides across Europe, but you can do it electronically. So it's basically, this kind of infrastructure opens up new possibilities to do a different type of research. And this is just an example. Moving on to the biobank support systems we have in TraIT. The cornerstone is the catalog. So the BBMRI-NL catalog, where we basically try to collect all sample repositories, but also data repositories, so the large cohorts that are available in the Netherlands, to make those cohorts findable and accessible to all scientists in the Netherlands and beyond, because we also try to link this to the European catalog that Petter presented this morning. And a nice thing you can do with this is really to make it also requestable. And again here, so this is the National Pathology Archive I was already mentioned in the use case. And traditionally these pathology archives look like this. So usually in the dungeons of the hospitals, because it's very heavy, so the floor weight is an issue as well. And it's very difficult to access that. But there are a huge number of records in there. And now with the catalog we created a public metadata repository where you can basically search this pathology archive. And and the number of records in there are really impressive. So it's over 30 million. And so when you want to identify, so when you have a use case like in the Netherlands breast cancer archive project I just showed, so you can simply search here in the public database. So how many breast cancer patients are there under 40 which don't have metastasis, which was basically the inclusion criteria for that study. So that data is still publicly available because it's not really identifying, and you can find it here and basically go out in this portal and order it. Of course, you have to go through an access committee then, so you have to do the scientific, go through the scientific evaluation, but then you get access to the samples from nearly all hospitals in the Netherlands using this procedure. Moving on to the next part is experimental data, so the various omics and non-omics pipelines we support in TraIT. I'm not going to say a lot about it, but one of the cornerstones in this area is Galaxy. So Galaxy is a very flexible pipelining tool where you can basically implement all your scripts and make them accessible for other scientists to reuse. And it's the way that a bioinformatician can publish the pipelines for other non-bioinformaticians to use those pipelines. One use case I want to highlight is a project that we do together with Elixir, where we basically take care of the complete provenance of the data. So we use their Transmart for the process data, we use Galaxy for the pipelines, and we use the Elixir EGA for the raw data. And so what you can do then is select a subcohort in Transmart, go back to EGA, get the raw data, and then go back to Galaxy and TraIT and rerun the pipeline that was used to create the process data in Transmart, or adjust the pipeline and do it slightly different because you think you can do better. So this way we have the complete provenance, not only the data and the process data, but also the analysis that were used in Galaxy. And I think we are pretty close to publishing this work in pretty soon. Data integration, Transmart. I'm not going to tell a lot about it because many people here know more about it than I do, and I thought it was more interesting to show the rest of the TraIT suite to this crowd. I just want to show one use case where we integrated Transmart with a lot of the other TraIT tools, and that's pretty typical for the way we would like to work with our projects. So this is a project in colorectal cancer, where we took a lot of tissue microarrays from tissue from colorectal patients in different stages, and we were looking for biomarkers in these patients basically prognostic biomarkers to predict disease outcome. And we used a whole suite of TraIT tools to capture the data and then bring into Transmart. And basically, we also would like to go back from Transmart to the original tools, again, to have the provenance in place. And what you see here is that we captured the clinical data in OpenClinica, so that's, and then linked that to Transmart. And we captured the tissue microarrays in TAPIS, so the images of it. And the annotations of these microarrays, so the experimental research in a tool called Phenotype Database, another open source tool that I didn't introduce. And then the sample locations, so we have a federated biobank in this project. So the sample locations are in the BBMRI catalog. So you can go back to the samples and basically reorder it and redo the analysis if you think you have a better biomarker. So here you see for one project, you see a complete suite of TraIT tools interacting with each other. All these TraIT tools are supported from one service desk. And why are we doing that? So that's because of this, basically production pipeline of new services. So what you usually see is when you identify a need for a service, you go out, identify solutions, look for open source solutions out on the internet, and you select the best candidate, and then you go out with a research project and implement it. And you show in practice that it works for that research project. And then you have a perfect demonstrator, and usually the engineer thinks that this time the job is done. It works, happy customer, so what else do you want? But then when you go out to the next project, then you see that it's slightly different. And then when you take more and more projects, you see it's completely not scalable, so you have to do a lot of work still. So basically, you're halfway. It's not only halfway in the scheme, but it's also halfway the work when you're at this stage. So there's still a lot of work to be done. And also, when there are many projects coming on board, the engineer cannot support it anymore. So basically, you not only need a factory, so the engineers producing new services, but you also need a shop. So where scientists can go and looking for support and have dedicated support staff helping them. And that's what we try to do in TraIT as well. And what I believe is one of the key success factors of TraIT. So we do have a service desk that people can call. We do have an email address that they can send emails to. But the other thing we also do is this self-service portal that I showed for OpenClinica, and which is very important to make it scalable. So when you have really common workflows that every project needs to go through, then most scientists can help themselves through this self-service portal. And that will help them to, will help us to keep the workload down, and will help them to get started very quickly. So, is it used? Yes, a lot. So in many projects, in oncology in particular, so that's the right half of the scheme, but also across many other diseases. Usage is increasing still pretty steeply. This is a slide from end of last year. We are over 3,000 now. And okay, so that's about TraIT. I have two or three more slides when you allow me. About the future. And when you look at the clinical studies we typically support in an environment like TraIT, we have only a very small part of the patients. But the data set is pretty complete. Then on the other hand, we are increasingly using clinical registries, which are pretty complete. And so maybe 80% of the data, but we use only a very few data elements. So we usually call that a minimal data set. So we purposely try to be pretty restrictive in what we collect. But then there is so much data out there that we're not using for research, and there's so much information hidden in it. So we need to find ways to also exploit this data, so the real-world data. And in the Netherlands, the Dutch UMCs collaborate in another project I'm involved in Data for Life Sciences, and this is one of the key objectives there, to make also this, basically this hidden germ available for science. And we do have a true north defined there, which basically says that all clinical data of all patients in the Netherlands should be available for every valid research question, of course under full protection of the patient's privacy. And when you think about it, then basically you would like to use every data point that's generated in clinical care, you would like to use in three manners. So first of all, for the patient itself, and then it should be identifying. Secondly, you would like to use it for quality benchmarking, so quality control across clinical care, and you're usually doing that anonymized. And then finally, you would like to use it pseudonymized for research and innovation. And when you are able to do this under full or at least acceptable protection of the patient's privacy, then we really have the holy grail. And I think that's what we are looking for in Helverai in the Netherlands. Thank you. That's what I...
Okay. Great talk and really nice landscape of how you're using it. I just wanted your comment on, you quickly rushed through CBio portal and your connection. So could you just talk a bit about that, how you're using it there?
Yeah, so yeah, I'm sorry about that. I made a selection of slides. Yeah, so Transmart is really doing the subsetting for you. So you can select subcohorts there. But when you want to look across the omics data and basically lay the patients on top of each other, then a tool like CBio portal is a lot better to have this cross-section. It's specific for cancer. There are no reasons it's specific for cancer, but but it is. We're still looking for use cases outside cancer. But yeah, currently we mainly use it for cancer. And what we do is that then for projects that like to use it, we export the data both to Transmart and CBio portal. So you can do the subset in Transmart in theory, and then import it in CBio portal and look further. But I still think we need the first project that really is using that productively. So we still are at this proof of concept stage.
All right. Thank you very much, Jan-Willem. I apologize if there's any other questions, but we're running just a little late now, so we'll better move on.